Please write on the heading. Algebra. Very, very important. You will see some of the very, very good methods to solve questions on algebra. If you see your sheet, please see your sheet. You will understand much more better if you see your sheet. If you see your sheet, I have divided the sheet into 5 types. Type 1 is based on remainder theorem. Type 2 is based on identity. That is a plus b whole square, a plus b whole cube, such kind of problems. Type 3 is based on equations. It can be quadratic equation, cubic equation, any kind of equation. Type 4 is based on factorization. And type 5 is based on problems on polynomials. And it is HCF or HCF polynomial. Right? These are 5 very, very good varieties in algebra. Let us start with the basic, very, very important topic. Please write down type 1. Problems based on remainder theorem. Problems based on remainder theorem. It's a very, very important topic for your examination. Problems based on remainder theorem. Right? See here. Before we start with the problems, first I will explain you the concept. First let us understand the concept. Suppose I have a quadratic equation. Suppose assume that I have a quadratic equation. X square minus 2x plus 1 equal to 0. Right? X square minus 2x plus 1 equal to 0. If I factorize it, I will get x minus 1 whole square equal to 0. That is nothing but x minus 1 into x minus 1. This is equal to 0. That means I can get it as x minus 1 equal to 0. So x is equal to 1. Right? That means x is equal to 1 is the root of the quadratic equation. Right? X is equal to 1 is the root of the solution of the quadratic equation. Now if you observe carefully, x is equal to 1 is the root. That means that if I substitute x is equal to 1 on the left hand side, if I substitute x is equal to 1 on the left hand side and simplify it, then I will get the value of the right hand side. Then both will be equal. Whatever the value which is present on the right hand side, if I substitute this value in the quadratic expression, x square minus 2x plus 1, if I substitute 1, then I will get equal to 0. That is right. That is why it is called as the root of a solution. Right? Now, x is equal to 1 is the root means, can I say that x minus 1 is a factor, x minus 1 is a factor of this expression, right? That means this x square minus 2x plus 1 can be written as x minus 1 into x minus 1. That means x minus 1 is nothing but a factor of this expression, x square minus 2x plus 1. Clear with that expression? Clear. Just based on this small concept what we have learned, we will solve some good number of questions. Right? We will solve good number of questions. Now see here. First sheet. Now if you see the sheet, I think there are some close to 10 very, very good questions in remainder theorem. Let us start with a very, very basic question. Please see the question. The question is, which of the following is a factor of x cube plus x square plus 37x minus 39. Which of the following is a factor of this expression is what is given. Now, what did I do? Suppose if the expression is x square minus 2x plus 1, then x minus 1 will be a factor. X minus 1 will be a factor. How did I get this x minus 1 as a factor? I did all the calculation what is need to be done. That means x square minus 2x plus 1 expression, I factorized it. I got it as x minus 1 into x minus 1. From there I got it as x minus 1 as a factor. Similarly, one way of solving it, x cube plus x square plus 37x minus 39. Factorize it. Because it is a quadratic expression, you are getting two roots and both of them are equal in this case. But because it is a cubic expression, you will get 3 roots or you will get 3 factors. Right? That means you need to factorize it. Then you will get the factors. That is one way of solving. Right? That is one way of solving. How to factorize the cubic expression we will see after some time. Right? Instead of doing all those factorization and wasting our time, just now I told you a concept. Suppose if x minus 1 is a factor, of x square minus 2x plus 1, then I should substitute it as x is equal to 1. That means minus 1 shifted to the other side, it becomes plus 1. X is equal to 1 if I substitute here, then that becomes a factor. Similarly, in this question also go by answer options. If I go by answer options, first option is x plus 2. That means I am substituting x is equal to minus 2. If I substitute x is equal to minus 2 here, I should get it as 0. But if I substitute x is equal to minus 2 here, I will not get it as 0. That means this is not a factor. Ruled out. Second option is x minus 1. X minus 1 means x is equal to 1. Substitute x is equal to 1 here. It becomes 1 cube plus 1 square plus 37 into 1 minus 39. If you simplify this, you will get 0. That means when I substituted x is equal to 1, I am getting the value as 0. Therefore, x is equal to 1 is a root, or in other words, x minus 1 is a factor of this cubic expression. Understand, right? That means the answer for this question is x minus 1. Option. Clear with the approach? You need not factorize it, sir. It's a very simple example what I discussed here. From that simple example, you can correlate with this. Similarly, solve it. Both of them are same concept. Clear with the approach? I will solve 3 to 4 questions, then you can write it down. Clear with it? Please see here. Suppose question number 2. Question number 2. Same example I will take. Now, x minus 1 is a factor of this expression x square minus 2x plus 1. Why x minus 1 is a factor? Suppose for example, suppose if I tell 3 is a factor of 9. 3 is a factor of 9. What is the meaning of this? 3 is a factor of 9 means 9 when divided by 3. 9 when divided by 3, my remainder will be equal to 0. Right? 9 when divided by 3, my remainder will be equal to 0. Similarly, if x minus 1 is a factor of x square minus 2x plus 1 means this becomes x square minus 2x plus 1. If I divide by x minus 1, the remainder should be 0. Right? The remainder should be 0. That means x minus 1 is nothing but x is equal to 1. If I substitute x is equal to 1 in the numerator, I should get it as 0. If I get it as 0, then it is a factor. If I do not get it as 0, then it is not a factor. It will have some remainder. That means whenever this is divided by this, always what I will get? I will always get the remainder when I substitute the denominator equating to 0. Clear with the approach? Same method I will apply for the second question also. Please see here. Second question. Question number 2. Your question number 2 says, if x minus 3 divides 2x square plus 3x plus 2, then the remainder is how much? They are telling us remainder when 2x square plus 3x plus 2 is divided by x minus 3 is divided by x minus 3. What is the remainder they are telling? Right? Now, how did I tell you? If I substitute x is equal to 1 here, whatever the value I am getting, that is the remainder. If I get it as 0, if I get the remainder as 0, then it is a factor. If I don't get the remainder as 0, it is not a factor. Right? Now, same logic applies here. Substitute x is equal to 3, you will get the remainder. So it is 2 into 3 square plus 3 into 3 plus 2. 9 into 2, 18. 18 plus 9 plus 2 is 29. Remainder when 2x square plus 3x plus 2 divided by x minus 3 is 29. You actually need not solve in this method, sir. X minus 3, 2x square plus 3x plus 2. If I divide it, here it is 2x square, here it is x. So it is 2x. This becomes 2x square minus 6x. Change the sign. If I change the sign, I will get it as 9x plus 2. Here it is 9x, here it is x. Multiply by 9. 9 into x is 9x. 9 into minus 3 is minus 27. Again change the sign. You will cancel this. 27 plus 2 is 29. These are all not required is what I am telling you. This is actually waste of usage. Right? Just substitute the denominator in the numerator. You will get the remainder very easy. Clear with the approach? Clear? Okay. That is your question number 2. First write down these two questions. Once you write it down, I will explain you some other question. Approach clear? Question number 3. Question number 3. Please see the question. Question number 3. The remainder when f of x is divided by x minus 5 is how much? Where f of x is given by x power 5 minus 4x power 4 plus 7x cube minus 11x minus 13. This when I divide by x minus 5, what is the remainder they are asking? Remainder when f of x, that is x power 5 minus 4x power 4 plus 7x cube minus 11x minus 13. When I divide by x minus 5, find the remainder is what I am telling. Right? Same logic whatever I applied here, apply in this problem also. That means substitute x is equal to which number? 5. Substitute x is equal to 5. If I put x is equal to 5 in the numerator, it becomes 5 over 5 minus 4 into 5 over 4 plus 7 into 5 cube minus 11 into 5 minus 13, right? Minus 13. Now if I simplify this, I will get some answer at the end, right? That is one way of simplifying that. Another way of simplifying is, if you observe all these things, all are a little bit of higher numbers, little bit higher numbers. If you are solving it in the normal way by simplifying, it will take a lot of time. Do not use that method. Apply only the unit digit concept. Play only with unit digit. 5 power 5 is always ending with 5 because 5 power any number will always end with 5. Now 5 power 4 will end with 5. 5 into 4 is 20. 20 will end with 0. 20 will end with 0. 5 cube is 125. It is also ending with 5. Ending with 5 into 7 is 35. That is also ending with 5 itself. This will also end with 5. Minus 11 into 5 is 55. It is ending with 5. Minus 13. It is ending with 3. Now if I simplify this, minus 5 plus 5 cancels. 2, 5 minus 3 is 2. That means answer the unit digit should be 2. We only played with unit digit here. Answer the unit digit should be 2. Check out the answer options. If you see the answer option, there is only one option which is having unit digit 2. Answer is 1, 4, 6. Even if you simplify this also, you still get the same answer. But it is waste of simplifying because it will take a lot of time to simplify. Clear the approach? If more than one option has the same unit digit, then go for some other technique. Or you can also, if you are good in digital sum, you can also apply digital sum. Whichever method you are comfortable. If you have more than one answer having the same unit digit, go with digital sum concept. If digital sum also has more than one option, then do the normal process. Understand it? These are some ways of saving the time in the examination so that you can save time and you can attend more number of questions. Clear? Please write down your question. Clear, right? Question number 3. Question number 4. Question number 4. Please see here. Question number 4 is, if x minus 3 is a factor of 3x square plus 3px plus 2p equal to 0, then find the value of p. They are telling that it is a factor. That means what they are telling is 3x square plus 3px plus 2p. If I divide by x minus 3 and if I find the remainder should be 0. Only when the remainder is 0, this will become the factor of this. Right? I already explained that. Now, again the same logic. I need to find this value of p. Substitute x is equal to 3. If I substitute x is equal to 3, 3 into 3 square is 3 cube plus 3 into p into 3 plus 2p. It is equal to 0. 27 plus 9p plus 2p is 11p is equal to 0. 27 p is equal to minus 27 by 1. Answer for this question is minus 27 by 1. These are not very easy questions once you understand this concept. We are telling that if x minus 1 is a factor of this, substitute x is equal to 1. Then the remainder will become 0. Same concept we are using. That is the reason I am not erasing this concept until this topic is completed. Right? Because of the same concept, we are solving multiple problems so that it becomes very, very easy for you to understand. Please write down. Clear? Question number 5. Before we move on to the next question, suppose I will call my function as x square minus 2x plus x plus 1. Assume that this is the expression x square minus 2x plus 1. Same expression I am taking, right? X square minus 2x plus 1. Now, what is the factor of this expression? The factor of x square minus 2x plus 1 is x minus 1. That means if I substitute x is equal to 1 here, that will give me 0. That is the meaning of it, right? That means substitute x is equal to 1. Substitute x is equal to 1. 1 square minus 2 into 1 plus 1. This will become to equal to 0. That means f of 1 is becoming 0. F of 1 becomes 0 means, can I tell that x minus whatever is there inside the bracket, that is 1. X minus 1 is a factor of that expression. Clear, right? That means if f of 1 becomes equal to 0, then x minus of whatever is there inside the bracket, put it here. X minus 1 is a factor of that expression. Same logic applies for the fifth question itself. Right? To the answer, your fifth question is If the polynomial f of x is such that f of minus 4 equal to 0, f of minus 4 equal to 0, then the factor of f of x is what? Now, same logic. If f of 1 equal to 0, then the factor is x minus whatever is there inside the bracket. If f of minus 4 equal to 0, then the factor is x minus whatever is there inside the bracket. That means x minus of minus 4 is x plus 4. X plus 4 is the factor. You actually need not get some expression like this. It will satisfy and then find out whether it is x plus 4 is a factor or not. It's a very simple cyclic process. That means if you understand this, you can reproduce the same thing here also. Right? You need not form the expression. Here I just took an expression for the example sake for you to understand. But actually you need not form an expression where f of minus 4 will become 0. It will take a lot of time. It is a waste of time. Clear? Just understand the concept. With concepts only we will multiply the question. We will solve many questions. Clear? Clear. Sixth one is an easy question. Once you understand this many questions, what should be the answer? 0. Right? What is the question? Reminder when x power 11 plus 1 is divided by x plus 1. What is the remainder they are asking? We already know how to find the remainder. Substitute x plus 1 equal to 0 or x is equal to minus 1. If I substitute x is equal to minus 1, this becomes minus 1 power 11 plus 1. Minus 1 power 11 is minus 1. Minus 1 plus 1 is 0. Remainder there. It's a very easy question. This has come in the examination. Clear? Approaches are clear, right? Now, please be here. Question number 7. Question number 7. Before solving the question number 7, first listen to this. Suppose if I take a statement. If I tell a statement, 3 is the factor of 6 and 9. 3 is the factor of 6 and 9. Now 3 is the factor of 6 and 9 actually, right? Now what is the meaning of this statement? 3 is the factor of 6 and 9. 3 is the factor of 6 and 9 means when I divide this 6 by 3, I will get a remainder 0, right? Because it is perfectly divisible. Similarly, when I divide this 9 also by the same number 3, I will get the remainder 0. Right? I will get the remainder 0. Clear the approach? Same application in your 7th question. Now see here. What is your 7th question? Your 7th question says x plus p is a factor of HCF. HCF is nothing but highest common factor. It is also a factor. X plus p is the factor of HCF of x square plus bx plus a and x square plus cx plus d. You need to find the value of p. You need to find this p value, right? It is exactly similar to 3 is the factor of or HCF of 6 and 9. It is exactly similar to that. That means remainder when 6 divided by 3 is 0. Similarly, remainder when x square plus bx plus a when divided by x plus p. This remainder will be equal to 0. And remainder when x square plus cx plus t when divided by x plus p. This remainder is also 0. Right? This remainder is also 0. Now, how will you find the remainder? Substitute x is equal to minus p in the numerator. If I substitute x is equal to minus p, this becomes, or you can also tell it as, now see here, right hand side of both the equations are same. Equate the left hand side. If I equate the left hand side and substitute it simultaneously, x is equal to minus p whole square plus b into minus p plus a. Equate it with left hand side of this. Minus p whole square plus c into minus p plus d. This will cancel. This is minus bp plus a is equal to minus cp plus d. They are asking p value. Bring it this side, bring it this side. Cp minus bp is equal to d minus a. P into c minus b is equal to d minus a. P is nothing but d minus a divided by c minus. It's a very simple. Wherever you get algebra, substitute by number, because algebra is nothing but variable is nothing but put some values, you will get the answer very easily. Wherever you have sentences like this, exactly similar sentence you put it in numbers, correlate it, apply the same logic what you apply in numbers. It becomes a very easy one. Clear? This is a very good question. Reminders of both of them are 0. Right hand side of both the equations are same. Equate the left hand side. How will you find the remainder? Substitute x is equal to minus p in the numerator. Simplify for the value of p. Please read. Clear with this 7 question? Please listen to this carefully. 8, 9, 10 are very good questions. First listen to this. Suppose your question is reminder when x square plus 3x plus 2 divided by x square plus 3x 4x plus 1, some number x square plus 4x plus 1. I need to find the remainder. Now see here. First let us do the normal process. If I divide this x square plus 4x plus 1, x square plus 3x plus 2, this is here it is x square, here it is x square. So I should multiply with 1. It becomes x square plus 4x plus 1. Now if I change the sign, this becomes minus x square plus x square cancels. This will become minus 4x plus 3x is minus x. 2 minus 1 is 1. That means what is the remainder that I got? When x square plus 3x plus 2 is divided by x square plus 4x plus 1, I am getting the remainder as minus x plus 1. This is what the remainder is what I am getting. Right? Now observe this very carefully. This is a quadratic equation or an expression. Quadratic expression. This is also a quadratic expression. Right? Forget about this being a quadratic expression. You take any polynomial expression in that place. Take any polynomial expression. Suppose this is any polynomial expression. Reminder when a polynomial expression is divided by an expression of degree 2. This polynomial expression is divided by an expression of degree 2. What is the remainder? You are getting a remainder with an expression of degree 1, or you are getting a remainder with an expression of degree 0. X power 0 is nothing but 1 itself, right? That means whenever you get, this is nothing but 1 actually. Whenever you divide any polynomial expression with an expression of degree 2, the possible remainders are, it will be degree 1 or degree 0. That means it will be less than 2, right? It will be less than 2. Similarly, reminder when a polynomial expression is divided by an expression of degree n, your possible reminder will be an expression of degree n minus 1 or even lesser than that, right? Or even lesser than that. This is what is very important. Now, if you observe this carefully, this is not only in case of algebra. Even if you take number system, still this rule is applicable. Suppose reminder when, suppose I take a number. Reminder when a number is divided by 3. Assume this number as 4. Assume it as 4. 4 when divided by 3. What is the remainder? 1. 5, next number change it. 5 when divided by 3. What is the remainder? 2. 6 when divided by 3. What is the remainder? 0. Next 7 when divided by 3. Again remainder is 1. 8 when divided by 3. Again remainder is 2. 9 when divided by 3. Again it is 0. Similarly, continue it. 10 when divided by 3. Remainder is 1. 11 when divided by 3. Remainder is 2. 12 when divided by 3. Remainder is 0. That means whenever any number is divided by an expression of degree n, or in this case a number 3. When a number is divided by a number 3, your possible remainders are the numbers which are less than 3. What are the remainders which are less than 3? 0, 1 and 2. That should be the possible remainders. Same explanation is in case of algebra also. Reminder, when a polynomial expression is divided by an expression of degree n, your possible remainder will be an expression of degree n minus 1, less than n, whatever it is, less than n. Clear with this? First write down this key point. First write down this key point.
Hold on.
Approach clear, right? See here. Now if you see the question numbers 8, 9 and 10, these are all very good questions. Listen to this carefully. Question number 8, 9 and 10. Question number 8. Question number 8. Reminder when x power 100 minus 2x power 99 plus x power 50 minus 2x power 49 plus x square plus x plus 1 whole thing divided by x minus 1 into x minus 2, right? X minus 1 into x minus 2. Now they are asking this reminder. Just now I told you the concept. Reminder when any polynomial expression is divided by an expression of degree 2. It is an expression of degree 2. If you multiply it becomes a quadratic equation, right? Reminder when any polynomial expression is divided by an expression of degree 2. The possible reminders are it will have an expression of degree 1 or it will have degree 0. Degree 0 is nothing but constant, right? Now ax plus b should be the reminder. Now how will you find the reminder? Substitute x is equal to 1, substitute x is equal to 2. Now first let me substitute x is equal to 1. If I substitute x is equal to 1, it becomes 1 power 100 minus 2 into 1 power 99, 1 power 50 minus 2 plus 1 plus 1 plus 1. Here it is a plus b. Here it is a plus b. If I simplify this, minus 2 plus 2 cancels. Plus 2 minus 2 cancels. You are left with 1. So a plus b is equal to 1 in the first equation. Right? A plus b equal to 1 in the first equation. Similarly, substitute x is equal to 2 here. If I substitute x is equal to 2, it becomes 2 power 100 minus 2 into 2 power 99 is again 2 power 100 plus 2 power 50 minus 2 into 2 power 49 is again 2 power 50 plus 2 square plus 2 plus 1. X is 2. It becomes 2a plus b. Right? It becomes 2a plus b. Again if I simplify, this will cancel, this will cancel. 4 plus 2 plus 1 is 7. So 2a plus b is equal to 7. This is my second equation. Right? Second equation. First equation is a plus b equal to 1. Second equation is 2a plus b equal to 7. Now if I solve these two equations, if I change the sign, this becomes minus b plus b cancels. A minus 2a is minus a. 1 minus 7 is minus 6. A is equal to 6. Right? A is equal to 6. Substitute a value of 6 here. This becomes 6 plus b is equal to 1. B is equal to 1 minus 6. It is minus 5. So a is 6, b is minus 5. And then asking the remainder. What is the remainder? Ax plus b. Ax plus b is a is equal to 6. B is equal to minus 5. Answer for this question is 6x minus 7. It's a very, very easy way of solving, sir. Do not get what do you say? Students will usually think like x power 100, x power 99, all those are very, very bigger numbers. So they will feel that this is a very difficult question. It is actually a very, very easy question. Clear with the approach? Any polynomial expression is divided by an expression of degree 2. The remainder should be expression of degree 1 or it should be a constant. Please write. Okay. Question number 9. Question number 9. Please see your 9th question. Same logic. Once you understand the concept, you should keep on applying the same concept. Reminder when x power 100 when divided by x square minus 3x plus 2. This is given in the question answer. Ax plus b. You need to find a and b values. You need to find a and b values. Now see here. Any polynomial expression when divided with an expression of degree 2. Possible remainders are degree 1 and degree 0. They themselves have given in the question. Even if they don't give it, you need to understand that it should be ax plus b. Same logic. Remainder x power 100 when divided by x square minus 3x plus 2 is x minus 1 into x minus 2. X square minus 2x minus 1x is minus 3x plus 2. It is the same thing. Is equal to ax plus b. First substitute x is equal to 1. If I substitute x is equal to 1, 1 power 100 is 1. Here x is equal to 1. 1 is equal to a plus b. This is my first equation. Substitute x is equal to 2. It becomes 2 power 100. We don't know the value of 2 power 100. Let us keep it as it is. This becomes 2a plus b. This is my second equation. Solve it. Minus minus, same the sign, minus. This will cancel. A minus 2a is minus a. This is 1 minus 2 power 100. But we want plus a. It becomes 2 power 100 minus 1. A value is 2 power 100 minus 1. Substitute this a value in this equation or this equation, whichever you are comfortable. I will substitute in equation 1. Equation 1 is equal to a plus b. 1 is equal to a value is 2 power 100 minus 1 plus b. This becomes 2 minus 2 power 100 is equal to b. B value is 2 minus 2 power 100. We don't know the values of 2 power 100. Let us keep it as 2 power 100. Clear? Later. It's a very easy way of solving it. Only thing you need to know the concept. Later. Okay. Question number 10. Question number 10. See here, it's a very good question. Listen to this. So many students will think that it's a very difficult question. How easily we can solve this question? Question number 10. Reminder 1. 81 power 21 plus 27 power 21 plus 9 power 21. 3 power 21 plus 1 divided by 3 power 20 plus 1. They are asking to find the remainder of this value, right? See here. Students will feel that these are all very bigger numbers. It's a very time consuming process. They will think that it is impossible to solve in the examination. See here. How easily beautifully we can solve now. If you observe here, 81, 27, 9, 3. Everything is nothing but 3 power something, right? Every number can be written as 3 power something. First write it as 3 power something. This is 3 power 4 power 21, 3 cube power 21, 3 square power 21, 3 power 21 plus 1 divided by 3 power 20 plus 1. Again, if you observe it carefully, this is 3 power 4 power 21 is a power m whole power n is a power mn. So it is 3 power 84. 4 into 21 is 84. 3 power 3 into 21 is 63. 3 power 42. 3 power 21 plus 1 divided by 3 power 20 plus 1, right? 3 power 20 plus 1. Now if you observe carefully, in denominator there is something called as 3 power 20, right? Every number express it as 3 power 20 into something. Now if I do it like this 3 power 84 can be written as 3 power 20 whole power 4, right? 3 power 20 whole power 4. How much happened here? 3 power 20 whole power 4 is 3 power 80, but here it is 3 power 84. Another 3 power 4 should be multiplied, right? Another 3 power 4 should be multiplied. Multiply that another 3 power 4. 3 power 4 is nothing but 81. Similarly, 3 power 63. Express it as 3 power 20. It can be written as 3 power 20 whole power 3. This becomes 3 power 60. But here it is 3 power 63. Another 3 power 3 should be multiplied. 3 power 3 multiplied. 3 power 3 is 27. This is 3 power 20 whole square. It is 3 power 40. Another 3 square is pending. 3 power 20 whole power 1. This is 3 power 20. But here it is 3 power 21. Another 3 power 1 is remaining. Plus 1. Whole thing divided by 3 power 20 plus 1, right? Now, if you are wondering why are we doing like this, now see here, it's a beautiful way of solving that. I will take this 3 power 20 as x. If I take this as x, the entire expression becomes remainder when 81 into 3 power 20 is x. it becomes x power 4. 81 x power 4 plus 27 x power 3 plus 9x square plus 3x plus 1 whole thing divided by x plus 1 whole thing divided by x plus 1. Now it is something like a very basic question what we have thought initially. How will you find the remainder for this? Substitute x is equal to minus 1 in the numerator. If I substitute x is equal to minus 1, 81 into minus 1 whole power 4 is 1. 27 into minus 1 whole cube is minus 1. 9 into minus 1 whole square is 1. 3 into minus 1 plus 1. 81 minus 27 is 54, right? It is 54. 54 plus 9 is 63. 63 minus 3 is 60. 60 plus 1 is 61. Answer for this question is 61. It's a very beautiful application of converting a number system problem to an algebraic problem. Where the approach very beautifully solved. Do not use any of those values which you know. You will not know that value. That is the reason this questions are given. You need to use the algebraic method to solve this kind of questions. Clear? Don't fear looking at these questions. These are not difficult questions. These are tricky questions. There is a difference between tricky question and a difficult question. These are not difficult. Once you understand the concept, this becomes very easy question. Clear? Please answer. Any doubts? Please answer.